and welcome to Cambridge Chemistry channel with Sarvatemma. There is another question of titration. A student determines the percentage of zinc oxide in mixture C containing both copper and zinc oxide. A sample of C is added to previously weighed beaker, which is then de-weighed. Mass of beaker plus C, that is 29.15, and mass of beaker is 25.30 gram. Calculate the mass of C used in this experiment. So the total mass minus mass of beaker. The total mass is with C is 29.15 minus 25.30, that is equal to 3.85. A 50 centimeter cube of 1 mole per dm cube sulfuric acid and excess is added to beaker containing the sample of C. The mixture is formed gently while being stirred and then left to stand for a few minutes. Zinc oxide reacts with sulfuric acid, but copper does not, because copper is insoluble in dilute sulfuric acid. Simple copper does not react with dilute sulfuric acid because copper is below than hydrogen ion in reactivity series, so copper does not react with dilute sulfuric acid. So zinc oxide can. The unreacted copper is settled at the bottom of the beaker and is removed by filtration. Construct an equation for the reaction between zinc oxide and the sulfuric acid. Zinc oxide plus sulfuric acid is equal to form zinc sulfate plus water. When the reaction has finished, the mixture is transferred to a volumetric flask and made up to 250 centimeter cube with distilled water. The solution is D. Using pipette, 25 centimeter cube of D is transferred into a conical flask and few drops of methyl orange indicator are added. A burette is filled with 0.100 mole per dm cube sodium hydroxide. Aqueous sodium hydroxide is run into the conical flask containing D until the end point is reached. What is the color change of the methyl orange during the reaction? The color changes from red to yellow because methyl orange is red in acid while yellow in sodium hydroxide. So this is red to yellow. Always start color change, always start from flask and the after the liquid entered in the conical flask from the burette. Now next is the fill the table. This is very important table to fill and you get the 4 marks to fill this table. This is final reading. So first you are supposed to write down always final reading first to fill the final reading. 25.2 and this is 0.0. This is 31.1 and initial reading is 6.8. Initial reading is 6.8. The final titration reading is 48.3 and this is 23.8. Initial reading is 23.8. So after subtracting from final initial from final reading, we get 24.5, over here 24.3 and 25.2. Select the best titration, and you know that the best titration which have smaller difference out of 3. So 24.3 and 24.5 have smaller difference, so we select these two readings. Using these results, the average volume of 0.100 mole per dm cube sodium hydroxide is 24.3 plus 24.5 divided by 2. So this is equal to 24.4. Calculate the number of moles of sodium hydroxide in the average volume of 0.100 mole per dm cube sodium hydroxide in D. Mole is equal to concentration into volume in centimeter cube divided by 1000. So this is 0.100 equal to 0.100 is concentration multiplied by 24.4 is volume divided by 1000. So this is 0.00244. Now sodium hydroxide react with sulfuric acid according to the following equation. Sodium hydroxide plus sulfuric acid to form sodium sulfate and water. Calculate the number of moles of sulfuric acid. We have moles of sodium hydroxide, so we can predict from this equation by using mole ratio. Sodium hydroxide 2 moles, sulfuric acid has 1 mole. So 2:1, and we have mole of sodium hydroxide 0.00244 ratio x. So this is equal to 0.00122 mole. Using your answer in F, calculate the moles of number of moles of sulfuric acid in 250 centimeter cube of D. So we know that 25 centimeter cube contains 0.00122 moles of sulfuric acid. So what would be the mole 250 centimeter cube? So this is x. So by using cross multiply, we get 0.0122 moles. Calculate the number of moles of sulfuric acid in 50 centimeter cube of sulfuric acid. That is the original sample. So mole is equal to, we know, concentration into volume divided by 1000, because volume is in centimeter cube. The concentration is 1.00 into 50 divided by 1000, and the answer is 0.05 moles. Using your answer in G and H, calculate the number of moles of sulfuric acid which reacts with the zinc oxide in the sample C. So by subtracting 0.05 moles minus 0.0122, and we get 0.0378. So this is the moles of sulfuric acid which react with the zinc oxide in sample C. Actual mole of sulfuric acid, H2SO4. Using your equation in B and your answer in 1. B in equation, we know zinc oxide plus H2SO4 to form zinc sulfate. This is the chemical equation which is given in B. So this is 1:1, and we have 0.378, 0.0378. Sorry. Wait, 0.0378 ratio x. The moles of zinc oxide are 0.0378. Calculate the mass of zinc oxide in the sample of C. Mole is equal to mass over mr. By using this equation, we know mass is equal to mole into mr of zinc oxide. Mole is equal to 0.0378 multiplied by 81. So this is mass of zinc oxide. Zinc is 65, oxygen is 16, so 6, 5, 11, or 6 and 1, 7 and 8. This is 81. So the answer is 3.06 gram. Gram is written over here. So this is using your answer in A and K. Calculate the percentage biomass of zinc oxide in the sample of C. So we know A and K. We know what is in A, 3.85. A is 3.85. So percent mass of zinc oxide in the sample of C. Percent mass of zinc oxide in C is equal to 3.06 divided by 3.85 into 100. So this is equal to 79.48. So approximately it is equal to 79.5. Okay, if you like this video, please subscribe and share this video.